I think that engineering requires experience, right?
Mhm.
And giving students a balance of fundamentals and practical examples that illustrate those fundamentals is important.
In this episode of Embedded Insiders, Marilyn C. Wolf, Professor of Engineering at the University of Nebraska-Lincoln, joins the podcast to discuss the importance of students understanding scope, having a balanced understanding of both hardware and software, and the needs of today's engineering workforce. Next, Rich and Vin are joined by John Janowiak, Executive Director of ECEDHA, the Electrical and Computer Engineering Department Heads Association, to discuss whose responsibility it is to prepare people for real work, whether it be schools, companies, or individuals. But first, Ken and I are giving our own opinions on these topics, pondering whether it's realistic to expect schools to fully prepare students for modern jobs, or whether companies should help teach and invest in the next generation of engineers. Hello, everyone, and welcome back to the Embedded Insiders podcast. I am Assistant Managing Editor Tiara Oliver, and I'm here with our Editor-in-Chief, Ken Briota.
Hello, Tiara. How goes it?
It goes good. How are you?
I'm very well, thank you. It is a lovely day here in New England in that we are awaiting more snow coming this weekend, maybe. So, but it's been warm. It's been over 40. It's been amazing.
That's good. Our weather over here has been pretty bipolar, but that's nothing new in Phoenix, so.
I just had a friend who was performing at the Arizona Renaissance Fair until last weekend, when I think it ended, and seems to have had a lovely time.
That's nice. I still have to go to
that. Well, I'm afraid you're gonna have to wait another year, I think.
Yeah. So just to get right into it, our two interviews this week are a little bit different than our usual interviewees. They're not engineers themselves. Well, no, former engineers, I'm sure. But anyways, the overarching topic is teaching and investing in this next generation of engineers, which is something I feel like we don't talk about enough. We don't talk about the students that are enrolled in these schools and, whose responsibility it truly is to prepare them for real world work, whether it be the school itself or the companies that employ them or themselves. So
the idea of who trains the next generation of engineers has, sort of always been, well, of course they'll go to college and do whatever, but the engineering fields, especially the double E's and like computer engineering, software engineering, have been advancing so quickly that by the time you've picked up your fundamentals in university and you're looking at advanced degrees or going to work, you're already out of date. You're already behind. And so it's a really interesting topic and a ridiculous challenge for the educators in those positions.
yes. So in the two upcoming podcasts, we'll hear from two different people. I did an interview with Marilyn Wolf, and she is a Elmer E. Coach Professor of Engineering at the University of Nebraska-Lincoln. And she just mentions briefly, the importance of understanding scope and having a balanced understanding of both hardware and software. And then Rich did a dev talk with Vin with John Janowiak. He is the executive director of the ECEDHA, which is the Electrical and Computer Engineering Department Heads Association, which kind of combines combines government, industry, and academia. I know Rich has attended. I almost had the opportunity to attend one year, but it's just a big convention sort of event where, different industry companies and academia join together and kind of talk about, what's needed in this in the upcoming workforce today. Yeah.
Yeah, I have not listened to that interview yet, and I'll have to check it out because I'd be very interested to hear what Janowiak is saying about what they're telling teachers to teach, what these companies are looking for in an engineer. Seems like that one in particular would be really interesting. Although I have listened to your Marilyn Wolf interview, and she's got some really interesting and cool ideas about this sort of synergy between hardware and software. So make sure you folks hang around to hear both of those. Um, I have a little bit of a hot take if you're interested in it, Tiara.
Oh, yes, please.
So, um, I think that undergraduate education in engineering has always been sort of just the basics. You almost always have to go on to graduate school to pick up a specialty and get into the nitty gritty. I'm beginning to think that engineering might have to start taking a page out of the trades book and start figuring out how to do internship or sort of apprenticeships, because they're as engineering fields become more and more entwined and more complex and advance quicker and quicker and quicker, on the job training is going to become super important. So I'm starting to think that we're going to need not just an engineer's apprenticeship, journeyman, and master engineer program. I think we're going to need a union. I think we're going to need a bunch of stuff for the benefit of educating engineers in these hyper complex topics. And I also think that they ought to be taking a whole bunch of ethics classes, but I've always thought that. Nobody's ever listened to me before.
No, I think that's a
So what do you
great take, honestly. I feel like that's something that Rich and Vin and John touched a little bit on the podcast about. There are some established companies out there. They mentioned Keysight and ARM, for example, who are more active in going into schools and providing classrooms with, whether it be examples of their work, like real world work, or it be their technology itself and having them learn on that. So I think
Yeah.
that's not quite where you're going, but I think it's a step in that direction. But I do think these companies should be investing more into the
Yeah.
students for sure.
I think that those kinds of programs are really interesting and good. I mean, I'm of the age where I remember when Apple was promoting the Apple IIe by giving away hundreds and thousands to schools, and my school got them, and so that was the first computer lab that I'd ever had in school and that my school had ever had, when I was in must have been middle school when that was going on. So like, that what that did, what Apple was hoping that would do, is turn all of us into lifelong Apple users.
Hmm.
What it did instead was some of us became lifelong Apple users for sure, but a lot of us just sort of got the basics of computing and then went out exploring, or sort of got a base, a thing to do. And that's why I think these things are valuable when one company, is out there saying, here, work on this, because you learn a lot of fundamentals hands on that way. But I think that you need a lot of companies to do that, so that we don't
Hmm.
have lock in on a particular platform. Because if that platform goes away or changes or whatever, you've got a bunch of engineers with skills that maybe don't translate super well to a different company or a different platform or different whatever. Maybe they do. I mean, it really depends on what you're talking about. If it's a company just showing off motherboards, yeah, those are all basically the same.
Yeah.
But if you're talking about a proprietary, silicon process or something like that they're letting these kids use, I say kids, they're adults, letting them use, then if they somehow, they get a job where they don't use that platform, they don't use that process, they do whatever, then they got to start from scratch again. So that's why I like the idea of sort of a vendor neutral or platform neutral apprenticeship,
Hmm.
perhaps run by, I mean, I also like the idea of running it through an independent organization like a union, um, because then they will be able to make these partnerships, work on the different platforms, teach their apprentices how to be well-rounded. We've seen that. I mean, it's worked with plumbers, it's worked with electricians, it's worked with all of the other trades, carpenters and everything for, a millennia functionally. And I think that it's maybe past time that a trade like being an engineer starts getting treated like that, because there's just so much to learn, and it takes a whole career to become an expert. It's not like you can ramp up quickly and be inventing new stuff instantly, I don't think, as a general rule, as an average and coming out of school engineer. You have so much that you have to learn. I have a lot of friends who are in mechanical and electrical engineering. I live in New England, and there's a lot of that around here. And they work for some of the biggest military contractors in the world, some of them headquartered here in Connecticut. You can guess who I'm talking about. But they come into these things and they all talk about their floundering. They have to learn everything the minute they walk in the door. And it would be to the benefit of these companies to support an organization that would allow them to hire engineers who walk in the door and know what they're about already, I think.
Yeah.
Not that I'm devaluing the college education process, but college has become a place where you get fundamentals. It used to be the place where you got your full career education. Now it's just fundamentals. And that's a very different rant, but I think I'd be very hard to convince that wasn't true.
Yeah. No, I think like going off of what you're saying a little bit, it would be cool. There's so many companies out there in so many different industries. I mean, we talk to them all the time. And I think it would be cool for them to employ some sort of program where, they have students kind of like you said, like an apprenticeship, but more companies should be doing it. So there's more variety out there. There's more things that you can try. So
Yeah.
there's not too many holes in the market and they're not entirely missing too much, if that makes sense. But
Yeah.
I think the smart companies should be communicating with universities, kind of going off the Dev Talk episode.
Yeah. I completely agree. I think that there's got to be a sort of university corporate pipeline where they're sort of talking back and forth, sharing needs and research and things like that. The pipeline has often historically flowed from the university in terms of both research and human assets to the companies. I
Mhm.
think I think the companies are going to have to start sharing backwards to the colleges. I think that's just going to become much more valuable and important, like what like what Rich Vin and John are talking about with ARM and OEMs and whatnot. Because if they don't start going back and saying this is what we need, that we're going to help train you on these things, in the short term, we're going to continue seeing an engineer shortage, which is what we're sitting on right now. And that's going to open the door to sloppy decisions, like
Mhm.
letting AI write all the code for products and things like that, which I think I've been very clear in the past in saying I think is sloppy, bad decision making.
Yes. No, I think we've definitely set the stage for these upcoming interviews very well. They'll be diving into it so much more, so I hope everyone stays tuned to listen. We've kind of just scratched the surface, but listen to the experts, hear their opinions because they've definitely got some very valuable information to share.
Absolutely. And don't forget to like and subscribe, everybody out there. You don't want to miss any of these episodes either here on your favorite podcasting platforms or on YouTube, where they go up in both places. And we have started an initiative under Tierra's leadership to bring a lot of our podcasts in video. So you can actually see some of us chatting and talking and watch our faces as we go, if that's your taste in podcasting. Let us know if it is. Drop a comment in there. Tell us if you like it. We're also going to be doing I'm very excited about this, live podcasting at Embedded World in a couple of weeks. We've got a whole studio that's going to be set up. So we've got a bunch of really fun live podcast episodes that will be going on onto our YouTube channel in just a couple of weeks.
Stay tuned, everyone. Now, here's Marilyn C. Wolf, Professor of Engineering at the University of Nebraska-Lincoln. So, Professor Wolf, thank you again for joining me on the Embedded Insiders podcast. Before we get started into some of my questions, I first wanted to, get to know a little bit more about you and how you got started in the embedded computing space, and kind of what your earlier interests were before you became a student and a professor.
Well, first, please call me Marilyn.
Okay.
I became interested in embedded computing in the 20th century when I was at AT&T Bell Laboratories. Our research group was concentrating on VLSI design automation, that is hardware design. And our department head, Al Dunlop, introduced us to someone in the consumer group who was building telephones and was singularly unimpressed with our capabilities for advanced integrated circuit design. He said, I can't afford to put that in my phones. I need to figure out how to design software for my telephone on an embedded microcontroller. That got my attention.
Mhm.
And I started thinking about the design challenges, because it was clear to me that although microprocessors at the time were very simple, that advances in hardware design would mean advances in the complexity and performance of this embedded software.
So today you're a professor at University of Nebraska-Lincoln, is that correct?
Right.
And then what specific courses, I guess, do you teach?
Well, first keep in mind that professors have responsibilities, beyond classroom teaching. We advise
Yes.
PhD students, we do research. University of Nebraska is a land grant institution that's ranked at R1. And so to some extent, research in engineering is baked into the law that enables our institutions. But I've worked generally in, shall we say, core embedded computing. I'm interested in both the hardware aspects as well as the software aspects of embedded computing. I spent a great deal of time thinking about embedded computer vision as an important example of that technology.
So my main interest today in my role at Embedded Computing Design, I interview a lot of engineers and developers about various topics relating to embedded systems, but rarely do we get to speak to educators and those who are in the classroom and speaking to those who are going to go on and be a part of these fields and these companies. So I like to scale back and see, what is going on in the classroom and how you're teaching these students to evolve with the technology that's evolving so quickly. So are there any embedded fundamentals that you follow and you believe are essential despite, the very many tools and platforms that are out there today?
Well, I identified several important aspects in embedded computing back in the 20th century, and put them into the first edition of my book, Computers as Components. And I still feel that those are core issues in embedded computing. That's real-time behavior, which means deadlines. That's low power, low energy. That is parallel computing, and that is also distributed.
And do you see any significant gaps between academic training and real world system development? Like, are there any specific concepts that you feel students are, consistently underestimating when they encounter these real systems?
Well, first, let's say generally that embedded computing requires a balanced understanding of hardware and software issues. For example, real-time performance depends not just on the software design, but also on the characteristics of the hardware platform. Same is true of low energy. Low energy computing is essentially tied to a lot of software characteristics, but it also depends upon the capabilities and characteristics of the underlying hardware platform. I think that an issue that is critical for industry, but hard to capture, at least in the more introductory courses, is the scope of these projects. We know that embedded computing systems now include millions of lines of code. They include, in some cases, well over 100 million lines of code. They're extremely long-lived in many cases. And because of the huge volumes of code, some of that comes from different sources, right? There may be some open source, there may be some purchased IP software. And of course, the hardware platforms become increasingly complex also. So I think that dealing with that scope is important. It is related to the kinds of issues that, for instance, web developers and data center developers need to consider, but with the added overlay of real time, low power, and so forth.
Gotcha. Are there any specific skills or a mindset that you believe today's students need the most as embedded systems become more autonomous and software driven?
Well, I think embedded computing systems have become more software driven since the 20th century.
Mhm.
Okay, as I said, we've got huge scale software systems already there. We've seen an explosion of AI and machine learning, and that has implications for both the design time activities as well as runtime in which you actually deploy. On the design side, one could use AI, machine learning tools to design both hardware and software. Once again, that has some relationship to what we see in other types of software engineering, but with the added constraints of real time, low power, as well as correctness. We also think that, we also see a lot of AI machine learning components deployed in the field, right? That these embedded systems have neural networks in them, for example. The types of AI machine learning techniques you would deploy in a low power system are somewhat different from what you would do in a data center. And so we've seen a lot of progress in the design, for example, of low power neural networks and machine learning systems.
So, in your perspective, maybe when you're getting new students into your classroom or new students that you're advising, is there anywhere you notice as far as their academic training where they still are falling short and being prepared for production of these embedded systems or getting started in the real world, looking for a job, whatever it may be?
Well, let's turn that around and say what does industry need to sharpen its tools on?
Yeah.
And I think that not all practitioners in industry have sufficient knowledge of some of these fundamentals
Hmm.
about real-time computing, about deadline-driven computing, about about the fundamental aspects of low power, about how to build parallel and distributed, systems that perform real-time and low-power operations.
Do you receive a lot of industry feedback or collaboration that influences how you structure your courses and how you advise your students?
Well, as I said, I got interested in this at Bell Labs.
Mhm,
I work with and talk to both hardware industries as well as system application industries, and I've been interested in a succession of application areas over the past years. Very interested in multimedia, which is a real-time operation, um, uh, embedded computer vision, which has applications in both static environments as well as on vehicles.
Are there any significant misconceptions about embedded systems education that you think need to be corrected today?
Um, I don't know if misconceptions is the right term. I do
Mhm,
think that the fundamentals are important, and I think that the scope of these systems puts them beyond, you know, sm- small devices, right? There are
mhm,
certainly small embedded devices out there, but if you take the example of automobiles, we've got huge amounts of software. We have networked systems that are performing real-time, safety-critical operations, and also have to obey some power constraints because there's a limited amount of power available on the vehicle.
mhm. So I know you have a lot of importance towards the fundamentals, which obviously completely makes sense. Is there any other piece of advice or guidance that you think educators training these engineers need to adopt?
Well, more generally speaking, I think that engineering requires experience, right?
Mhm,
And giving students a balance of fundamentals and practical examples that illustrate those fundamentals is important.
mhm,
And we also talked about, the large scope of some of these real world systems. Engineering is a team sport, and our students need to have the um, collaborative skills and communication skills that are needed for these large projects, as well as the associated technical skills.
And for my last question, I really just want to know if there's anything that you believe I might have missed or anything else you'd like to add that you think would be beneficial to those watching or listening to this interview, about training the next generation of engineers and how this is evolving so quickly.
Well, you've done a great job, and I really appreciate the chance to talk to you and your audience. I will say that we have huge needs for workforce, um, and embedded computing is an important part of that.
Mhm,
um, we need to be able to utilize the chips that we make and put them into real world systems. We also, of course, need to be able to maintain and upgrade those systems. So I think there's opportunities for a wide range of technical training for people in the embedded system space, ranging from sort of hardcore hardware design up through system design and through deployment.
Now, here's Rich, Ben, and John Janowiak, Executive Director of ECEDHA.
Good afternoon. Welcome to the Dev Talk with Rich and Vin podcast. I'm Rich, the guy up there near the corner is Vin. How you doing, Vin?
I'm great, Rich. How are you?
I am doing just fine. You look like you're in a weird place. Where are you?
I'm actually on site at a client, but always can make time to do these podcasts because I think they're really important and, get my biweekly dose of Rich Nass. So
Where is your client?
outside of Atlanta, outside of
Oh,
Atlanta. Yeah.
Okay.
So we're working on some technology and some organizational stuff, and looking at how we can bring new college grads in to sort of refresh some things and get new perspectives. And obviously they're
Yeah,
taught different things than we were taught 20 years ago, 30 years ago, 40 years ago. So
you can come visit me because at our local Daytona airport, there's 5 flights a day, and every one of them goes to Atlanta.
it must be Delta. There's an old saying when I lived in the Northeast as a kid, you couldn't go to heaven out of Florida without going through Atlanta. So
Yep.
that was,
Yep. If you want to be
yeah.
Delta, that's what you got to do. Anyway,
Yeah, for sure.
so, okay, so back up. What are you saying here about connecting people with academia and industry and that kind of thing?
Well, I was thinking about this a lot the other day because I have a friend. I don't know if you ever watched the TV series Suits.
I love
but
Suits. I'm
yeah.
Harvey.
Okay. Well, you're Harvey. I thought I was Harvey. That's not fair. I think you're Louis Litt. Anyway. Anyway, for those people who don't watch it, it's definitely worth a watch. But I have a friend who just started watching it, and we were talking about it, and I was joking that it's a law firm, they only want to hire students out of Harvard, and it got me thinking about STEM. And it's a TV show. It's obviously fake.
So you would only hire people out of Stevens? Is that what you're saying?
Well, I might only hire people out of Stevens. You might only hire people out of New Jersey Institute of Technology. So we'll see. But, I started thinking about the relationship between businesses and the schools they come from. And
is there one?
Well, there isn't as strong a one as there should be. And I think for decades we got by because there was a lot of practical knowledge and a lot of labs that were taught with the theory in schools. But now there's so much theory to be taught on the STEM side that.
But it was always like, hey, donate equipment to the school, get them used to our equipment. So then when they graduate, they can come work for us because they already know how to use our equipment. And that was like the extent of it for so long.
Yeah, that's great. If you're Tektronix or HP or somebody like that, it's not HP anymore, it's Keysight.
But even on the software side too, the people with software tools were doing the same thing.
Yes, but what do you do for somebody who's building HVAC or somebody who's building motor control or somebody who's building industrial equipment, right? They are not going to donate. Branson Ultrasonics isn't going to donate welders to Stevens or New Jersey Institute of Technology. So somebody coming out knows how to weld plastic. And the controls now are a part of everything. So electrical engineering especially is hidden inside products that would be used in the labs. And so who do you get to design those controls? And I started thinking about a new model, and we talked about this briefly when we had Kevin on a few weeks ago, a new model for how we help students transition from academia to industry. And, there's an organization that has already done a really good job of this for a very long time, but a lot of people don't know about it. And I think in our listenership, that's very true. So I think we ought to talk about what they do and how they do it. The organization is called ECEDHA. It's the Electrical and Computer Engineering Department Heads Association. They meet all year and they have an annual conference, which brings industry and academia together. And luckily,
but how well is that attended? Like who actually goes to these things?
Well, you know what? I think we ought to bring an expert on to talk about it. We just happen to have the person running ECEDHA, who's actually his dad co-founded it decades ago. So, and it turns out it's somebody you know from your past as well. So this time I'm going to let you introduce him because you guys are old friends.
John Janowiak. I actually have no idea what your title is these days, but welcome to the podcast, John.
Oh, Rich, it's so good to see you. And Vin, thanks for having me.
So what is your role here with this association that Vin described?
I've been fortunate to be part of some of the leading technical nonprofits my whole career. And so I have basically a nonprofit management or an association management company that I manage several 501c3s and foundations and all in advanced technology. And so, I think our past, Rich, was back in the old EDA design con days that we crossed paths and
that is correct.
Right. And that was under an organization called the International Engineering Consortium. But I run things like the Marconi Society, which is the international nonprofit in advanced technologies and wireless AI and quantum, and so and several other industry nonprofits. But the one that's most relevant for our conversation here today is an academic nonprofit that mentioned, which is the ECEDHA organization. And literally, I was around, straight out of college 43 years ago. My father had, got a request from Georgia Tech, NC State, University of Florida, Clemson University to help set up this collaboration between all the department heads in the Southeast. And quickly we embraced it and grew it into a national and an international organization, which brings together, all the ECE chairs, in North America, so US and Canada.
And what's the charter? Just
the charter it's really to help them collaborate and catalyze everything from curriculum to labs to research to grants, federal funding, private funding, and corporate relations. And so what we've done is, we have all, really the three pillars, government, industry, and academia all collaborating together. And
what's the industry contribution to that?
It's tech in general, it's EDA, it's robotics, it's anything, the target is the electrical and computer engineering department. So any industry that really requires ECE at its core is where we intersect with industry, which is if you think about disciplines, ECE is the broadest discipline. I mean, it really is in terms of engineering. And so, I love introducing the organization to, new areas. Obviously, we're working real hard these days in machine learning and artificial intelligence and other areas, quantum. So, it's a dynamic organization. We have approximately, out of the 300 ECE departments, about 280 as members. And so a very high penetration. Normally what we do is the turnover as a department chair is relatively high. So, we're constantly trying to renew the membership with people that we're missing. But it's everyone from MIT down to the state school. And so, we have a tiered membership from a dues structure, but also services. We help the teaching colleges and we help the R1s.
Hold on.
Sure.
Why did you say it that way, from the MIT down to the state school? Like the state school is the bottom of the barrel there.
No.
I'm a product of the state school, and I think it's a damn good state school.
Not at all. As a matter of fact, there's for the top, R1s, that their teaching mantra is somewhat less than they're more into research versus the ones that are at the bottom of the research or curriculum and enrollments. Those are as important or more important than in the R1s in terms of information, new technologies, learning, pedagogy, new pedagogy methodologies. I mean, there's all sorts of things. The needs are different. That's what I was trying to explain, Rich, is the needs for the research ones and the needs for the teaching colleges are different. And we have programs that hopefully help, each one of those categories of engineering schools.
Okay. Yeah. So back to my original question, though. What's the industry involvement in this? I understand where the academia is involved. Yeah. Do you have practicing engineers coming into the organization to say, hey, this is the way you need to be teaching because this is what they're going to face when they get out in the real world?
Yeah. On our pre-call, you mentioned something where, you'd have industry supporting academic curriculum through their technology. And that is, something that a few key industrialists years ago cracked. The two that I loved was Bill and Dave. from HP. They knew if you had the engineers, today's practicing engineers, practicing on and using your equipment in the lab, they were going to come out on top, because you're basically, having all these new grads that want their, latest technologies and their latest devices in their workplace, in their new workplaces. So it was it's a long marketing channel in terms of investing in the universities. But honestly, that pipeline is critical, and you're still finding how companies struggle with that pipeline. And the real, getting to the core, which is in higher education, is the best way to tap into that pipeline.
Yeah, and I've seen this actually from both sides because, as you know, I've been an adjunct professor, but I've also been in industry for years. And
Right.
one of the things that companies have struggled with is, hey, we'd love to help universities learn how to use our equipment or learn how to design with our chips or whatever, but we don't understand the way they're teaching and what information we need to provide to them to effectively support the classroom experience, right? And so industries
Right.
get that information from the people at this organization or the people in their organizations at the school, right? The department head will connect them with the professor and they'll say, hey, we're teaching circuits one. We really need a way to visualize how current is flowing or what happens with power or whatever. And you get a company like Keysight who has the ability to look at these signals, or you get a company like ADI or Renesas or whoever who make the chips, and they will be able to provide the kind of resource material that can be used in the classroom. So the companies learn that and contribute that. And of course, they're branded and people know their name when they get out of school. You and I have talked about this before, Rich. One of the reasons ARM is so ubiquitous is because they invested in the universities. And when kids
Yep.
got out, they knew that architecture, and that's the architecture that they picked, right? So
But
this
what
is a
about the
proven
OEMs?
model.
Like Whirlpool, for example. How does this help them? They want people to know their stuff and come work for them.
Oh,
Or
well, because
or
yeah,
the automakers is another example.
because they know their long-term vision and they know the skills that they need 5 years out. And so they can say to the universities, hey, we see emerging in our industry AI being used in controls, or touchscreens being used in our controls, or higher integration in chips. So it's no longer a board level design, it's now a chip level design.
But are
So
those companies seeding the universities? I mean,
they
let's
are
use the white goods people for
well,
as
the-
an
The
example.
smart ones are rich.
yes, the smart ones are. Yeah.
Okay.
Yeah,
I was not aware of that. That's great.
well, the thing, Rich, is, and I just alluded to it. It is a long play. It's not something that they're going to be able to measure the ROI right away. It is it's getting your brand out, getting your technology out when the kids are learning. I mean, that's and talk about the perfect time to introduce your products and services is by providing those to students, and being part of the curriculum is sort of the golden egg in terms of corporate involvement in academia. Now it comes at a cost, and it comes at you know uh, a dedicated effort. I've seen companies come in and they're like, oh yeah, gung ho, and they only do it for a couple of years, and you get a bean counter. Hate to say it, you get a bean counter, and they're like, show me the ROI. Well, there is not a measurement for ROI in terms of dedicating, and really investing in the next generation of engineers. That's what I love working with companies. I know you've mentioned Keysight a couple times here, and other companies. All the
Yeah.
ones you've mentioned are actually part of our organization as
Yeah.
corporate members, and they understand that you can't. This is not a one and done, or a 2-3 year commit. This is a multiple year commitment, and it's also something that these young engineers walk away with, and they have an affinity for the products, the services, the culture. I mean, and that's still alive today. So I mean, I think it's important that engineers feel supported. Engineers feel that they can, rely on, technology companies that give back and invest. And so, and certainly, it's not all altruistic. These companies are looking for the latest engineers to come and work for them, and the best engineers. And so, establishing that one-on-one relationship with industry allows the companies to get close and have influence on the curriculums, so that they're graduating engineers that can come in and immediately be effective in their organizations. Now, AI is changing a lot, and so there's a paradigm shift happening, in terms of hiring new engineers, and it hasn't, in my opinion, it hasn't shook out yet. As a matter of fact, you mentioned our annual meeting for this organization, the ECEDHA conference. It's in March, and right now we have an AI accelerator program. I call it the AI accelerator because AI is accelerating how we're teaching, what we're teaching, and what are the core elements that every student needs when they walk out of there. So this AI accelerator actually is, we had it as a special pre-conference workshop. It's outstripped the conference. Everyone in academia is trying to figure out how they address AI in the curriculum, how they address AI in the lab, how they address AI, embedded into, everything that an engineer is learning. So there's a new paradigm out there that's, quickly adopting. And I'm talking to faculties, Rich and Vint, and they're like, if we don't do this, it's like the old days, are we going to still use the slide rule, or are we going to use that new thing called the computer?
Well,
I mean, that's the analogy I can make here.
Yeah,
this might be a little outside of this might be outside of your purview, but are we at the point where what we're teaching these engineers, the graduating engineers, they don't actually need those skills anymore, because those skills are going to be handled by the AI. So we need to teach them something different.
I disagree. I think it's changing the opportunities for new grads, but they need the skills to understand and interpret what the AI is generating to make sure that it's still correct, because AI is not flawless, right? So
right, but isn't the AI doing that first job that the engineer had to do?
Yes, it's
and that's what the schools are training these kids for. That thing that they don't need to do anymore. They need to do something different. So have we changed the academic program to? Okay.
Rich,
this is just like we're in court, John, and when you shake your head, the audience can't see you.
I'm
You're on record as saying no.
I'm shaking my head in agreement with you, because the ignorance that I see, and I shouldn't say ignorance, the sort of bury your head in the sand, approach that some of these academic institutions take. I mean, they're going to get their lunch eaten. I mean, if they don't embrace AI into the curriculum. And Vint, I know you understand the premise of the fundamentals, and teaching the fundamentals is real important. Yet it's not as necessary, as to Rich's point, as it has been in the past.
No, I agree.
And you turn off some of the best engineers on, at least in our discipline, ECE, and they become, I don't mean to say this is a lesser discipline, but they become MEs, or they become, they get.
Oh, it's definitely a lesser discipline.
No, you're right.
You said it,
right.
I didn't, Rich.
But you have to be careful. John, you mentioned bean counters, but it's not just bean counters. It's CEOs, or the C-suite, and the finance people and the marketing people. What you don't want to do is say, oh, They don't need to know anything. It's, you can't design
No,
products with
no.
Arduino either, right? I mean, Arduino is a good prototyping tool, but not something you'd ship a product with. And it's the same thing. You don't want to just ship code that's been written by AI and nobody's looked at it and verified it. So you have to find a new balance. I mean, I tell students,
my point, that now the engineer, his first level is verifying that code. It's where it used to be writing the code.
Writing the code.
Yes,
right.
for sure,
Absolutely,
for sure.
Rich.
Right.
Yeah. But the fundamentals are still a requirement, but quickly it's using today's advanced tools through AI, machine learning, and other tools that is going to be effective. So embedding those into, after you're done with embedding those into the curriculum and the labs is critical, and partnering with companies that are pushing the envelope in those areas is critical. So I look at it as you guys are making me tell all my secrets. CS, come on, Rich, it's been eating our lunch, for ECE for the last, couple of decade. Now, if you look at the enrollment, CS is, and ECE is going way up. And that's because this is the era of advanced engineering, advanced information technologies, and intelligence, and it's back to the broad-based understanding of engineering, technologies, systems, and infrastructure is really the core of ECE, and that gives you the basis that you can take anywhere. But AI is here to stay. It's here, and the universities that embed it into their curriculums, embed it into their labs, and embrace it are going to be so much more advanced and further ahead than ones that don't. And I was on campuses. I was down in Florida, Rich, as I mentioned in our pre-meeting. I went and saw 4 universities. 3 are embracing. 1 was sort of making it a nice feel good. I'll tell you, if you don't embrace it quickly, the world's passing you by.
Yeah.
You work with universities outside the United States, John?
I do in my other roles. I just came off a call with the University of Bologna a few minutes ago. One of the oldest universities in the world.
Yeah, the oldest.
And it is. It is the oldest. Yeah.
So what's your feeling with how, who's ahead, who's behind, or is geography irrelevant?
No, it's not irrelevant. I think, the countries that are investing in AI, obviously, are having, I can't say this for ourselves anymore, but, the countries that are investing in AI, it does trickle into the universities. This administration obviously doesn't hold that opinion. This administration feels like the universities are rich enough and they should do their own thing. I mean, it's a dark time for academia and government relations. We're missing this opportunity, because I work all over the world. We're missing this opportunity of losing our technology's dominance, and AI is a big part of that. Fortunately, we have the infrastructure from the corporate side and research side to support it right now, but that's not going to last. I don't know if it'll last the next 3 years.
Right. And it's an interesting point because, Rich, you and I are very, very familiar with industry conferences where companies who are competitors are competing even at the conference. But the feeling on the expo floor at the ECEDHA conference is completely the opposite. You got, you look at, we talked about Keysight, but Fluke is there. Tech is there. So, and even the PC scopes are, the people have plug-in equipment on USB that are realized on PCs, right? They are all there. They are sharing their knowledge, that they are working together to move in a single direction, because this for them is not about current revenue. It's not about competition. It's about the future for society in general. This is part of their community give back. I mean, you've heard me talk about this, right? The five stakeholders in any business are investors, customers, employees, suppliers and partners, and the community. And this is very much a community thing so that the community of engineering is moving forward and they're working together. And you don't see that level of cooperation on other show floors because they're vying for people's eyes. But in this conference, they're not vying for people's eyes for their business. They're all working together to move the industry forward. And even, people like DigiKey are on the floor, who are distributors for this equipment, and Test Equity is on the floor, distributors for this equipment, and they're all working together to help things. So it's actually a societally inspiring conference. I love going to this conference, and I've been there 12 out of 15 years, John. I mean, I've been there a lot. Yeah.
Wow, that's great. Yeah, no, I mean, there is, I'd have to say, sort of a higher purpose and mission that the companies that are there, as well as the academics, the collaboration that happens on the academic side is very timely. There is this enormous free flow sharing of information about how effective you can make your curriculum and labs function together. Research dollars, which is obviously something that's been affected by this administration, but learning how to be effective researchers and PIs, and I mean, it's just it's a wealth of knowledge and people working together, to support our industries that we have there. So but Rich, we should have you come out at some point. I know you and I have intersected on some of the industry activities we've run. But I think you would really be right at home.
I very much welcome that. So if people want to get more information, where would they go?
ECEDHA.org, ECEDHA.org. Okay. And the program that we've been referring to is coming up in actually it's a very cool location. It's between Santa Fe and Albuquerque on this Indian reservation, and it's a beautiful resort
place.
called the Hyatt Tamaya, and it's owned by the tribal nation there, and it's a 4 or 5 star resort, and it's a kind of a mystical place, but it allows if you're away from everything, there's no towns or anything around there. And so it's truly this incubator, I would say, of really smart people and great technologies, all kind of designed to serve the next generation of engineers.
Yeah. And the last couple of years, I've been doing some video to put together a long form social media post on the conference. And Rich, I'd like to finish that up this week and have you guys post it along with this podcast on the website. I think that would be a really cool thing. And I would encourage any of our listeners, we talk about big companies, but this is not an organization just for big companies to join. Smaller companies who want to see technology evolve, want to be able to work with students, want to have insight and some influence on what's going on in universities. This is the perfect forum to make that happen. So I would encourage companies of all sizes to get involved with the organization.
Awesome. Yeah, and Rich, one of the things, I've run some of the largest trade shows and conventions all over the world, and we apply all of our best practices to this, relatively small community. It's about 500 to 700 people that come to it, and it's really quite magical. We feed, I think the latest information, but we also feed the interpersonal relationships and connections and networking at this as much as the technical side, because it's critical that engineers, learn from each other and build those relationships, that trusted relationship that they can utilize in their careers and their research.
Very good. Well, thank you, John. I really appreciate you taking the time.
Yeah, it's great to see you, Rick. Yeah, thank you for having me.
Educate Vin for sure, but to educate the audience, that's the important part.
Yeah. Well, listen, anytime. I enjoy working with you guys.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.